Hey everyone, welcome back. So today, we're going to talk about something that is totally changing the game when it comes to thinking about uncertainty. It's called Bayesian thinking, and honestly, it's a surprisingly simple but incredibly powerful way to update what we believe when we get new information. And to really get how it works, let's just start with a situation we can all understand.
So picture this. You go to the doctor, you tell them your symptoms. They don't have a crystal ball, right? They can't know for sure what's going on. They start with an initial hunch, based on their experience. Then they run a test, and that test, that's new evidence. And with that, they update their diagnosis. They're actually thinking like a Bayesian, whether they know it or not. And that process is exactly what we're going to unpack today.
So here's our game plan. We're going to break this down into 5 simple steps. First, we'll tackle the whole idea of certainty itself. Then, we'll look at the actual recipe for forming beliefs. After that, we'll dig into our starting assumptions, see the real power of new data, and then, finally, we'll see why this whole way of thinking kind of changes everything.
Okay, so, at its heart, Bayesian thinking is really just a formal system for doing what our brains do naturally all day, every day. You start with a belief, you see or hear something new, and you adjust that belief. It's basically a structured way of changing your mind, of moving from being less sure about something to being more sure.
Now, I know this might sound a little complex, but the beautiful thing about it is that it all boils down to a really simple 3-part recipe. Yeah, seriously. Just think of it as 3 core ingredients you need to make a smarter judgment about, well, pretty much anything. Let's take a look at them. So the first ingredient is what we call the prior. Let's go back to our doctor. The prior is their initial hunch. Based on your symptoms and all their medical training, they might think, there's probably a 60% chance this is just the flu, but maybe a 10% chance it's something rarer. That first gut feeling before any new tests, that's the prior.
Next up is the likelihood. Now this is the really cool part. It's not just the new evidence, like a lab result. It's about asking a deeper question. If my initial hunch was right, how likely is it that I would see this exact result? So if the doctor thinks it's the flu, how likely is this particular blood test reading? A really accurate test that screams flu gives you a powerful likelihood. An ambiguous test? That's a weak one. It's all about the strength of the new info.
And that brings us to the final ingredient, the posterior. This is the payoff. It's what you get when you combine your initial hunch, the prior, with the strength of that new evidence, the likelihood. The posterior is the doctor's new, updated diagnosis. It's a more informed, more accurate belief than what they started with. It's the aha moment.
So you can really just think of it like this simple formula right here. You take your starting belief, your prior, you multiply it by the strength of the new evidence, the likelihood, and what comes out the other side is your new, updated belief, the posterior. It's this simple but incredibly powerful engine for learning and for updating what you think you know. That right there is the core of it all.
Okay, let's dig into our next section, because this is where it gets really interesting. We talked about the prior, that starting belief, but it turns out not all starting points are created equal. The kind of prior you pick can actually make a huge difference in your final conclusion.
You basically have a few options for your starting point. You can go with what's called an informative prior. That's our strong hunch. You'd use this if you already have a ton of data or experience in a subject. Or you could go the complete opposite route with a non-informative prior, which we're calling the open mind. That's like saying, you know what, I'm starting from scratch here. I have no idea. And then for the real math nerds out there are things called conjugate priors. Just think of those as a helpful shortcut. They're basically mathematical pairings that make the number crunching part a whole lot easier. The key takeaway is that your starting point is always a conscious choice.
All right, this brings us to what might be the single biggest advantage of thinking this way. You see, a lot of traditional methods just spit out one single answer, which can sound really definitive. But the Bayesian way, well, it gives you something much, much richer, and frankly, a lot more honest about the world.
I mean, just look at the difference here. On the left, you get the classical answer, the patient has disease X, period. End of story. But on the right, look at the Bayesian answer. It reflects the real-world uncertainty. It says, okay, we're now 85% sure it's disease X, but hey, there's still a 10% chance it's Y and a 5% chance it's something else we haven't thought of. It doesn't just give you an answer, it tells you how confident you should be in that answer.
And that is the absolute key. You're not just getting a single data point, you are getting a full probability distribution. It's like getting a complete map of your own uncertainty. It shows you what's most likely, sure, but it also shows you all the other possibilities and just how likely they are. It's a totally different way of seeing the world.
So why is this such a big deal?
Why does it change everything? Because this way of thinking, of methodically updating our beliefs when faced with uncertainty, it's like a superpower. And it's being used in some of the most critical and complex fields you can imagine.
Seriously, think about it. From doctors making life-or-death calls to the actual algorithms that power AI and machine learning. From economists trying to predict where the market is going to scientists building models of our climate, this framework for reasoning is absolutely everywhere. It's a universal tool for making smarter bets in an uncertain world.
So, to wrap it all up, its power really comes down to a few huge advantages. First, it gives you a formal way to use what you already know. It's also amazing in situations where you don't have a lot of data to work with. And maybe most importantly, it gives you a much deeper sense of how much you should actually trust your own conclusions.
And that leaves us with one last really fascinating question to think about. We're using these exact principles to build smarter, more adaptive artificial intelligence. So the real challenge for all of us is, how can we consciously use this same recipe in our own lives? Start with our beliefs, actively look for new evidence, and then have the courage to update our views. How can we use this to become clearer, more rational, and ultimately smarter thinkers?